So, good afternoon, everybody. Welcome back to class. It has been a long break, and I would like to welcome you back. Now, I would like us to immediately get back from where we left off. We'll continue in session 5. So, we look at Transact SQL. Now, the objectives for the sessions are given below. So, we look at T-SQL. Look at the different categories of T-SQL statements, explain the various data types supported by T-SQL, look at the various T-SQL language statements, explain sets and predicate logic. You remember before we left, I told you to go and read more on set theory. So if you haven't done that, you might find some of the concepts here a little bit hard to grasp. But I'm quite sure you did that. We'll also describe the logical order of operators in the select statement, which is very, very important, not only for this session, but also for the programming sessions we'll be looking at later. We'll be looking at this statement when looking at something like Java, C#, Android, and most of the other programming languages, because what we are covering here will form the back end of the applications we'll be developing later. Okay, introduction. Now, SQL is the universal language used in the database world. And actually, we talked about it being developed as a standard in the 1970s. And most modern relational database management products use some type of SQL dialect as their primary query language. SQL can be used to create or destroy objects such as tables on the database server, and to do things with those objects such as put data in them or to query for the data. T-SQL is a Microsoft implementation of the SQL standard. Actually, there are several implementations. You can find out more on them, but I don't want to deviate into that. And basically, Transact SQL is abbreviated as T-SQL, and this language implements a standardized way to communicate to the database. The T-SQL language is an enhancement to SQL. The ANSI, that is the American National Standard Institute, relational database language. It provides a comprehensive language which supports defining tables, inserting, deleting, updating, and accessing the data in the database. And we call these CRUD operations. Now, T-SQL is a powerful language offering features such as data types. We also have temporary objects and extended stored procedures. And actually, this is just the tip of the iceberg. We also have scrollable cursors, conditional processing, transactional control, and exception and error handling are also provided. The T-SQL language in SQL Server 2012 and also 2016, which we'll be looking at, provides improved performance, increased functionality, and enhanced features. Enhancements include scalar functions, paging, sequences, metadata discovery, and better error handling support. Now, I know some of these things, they seem to be so abstract, but we'll look at them as we move on. So the following snippet shows a T-SQL statement, select, and actually this is the most commonly used. And we use this to get or to retrieve records of employees whose job title is design engineer. And this is being obtained from the select table. So you can see we have the select keyword. So we want to get the login ID. The name of the table is employee. That is where we have from employee. And then we specify how we want to filter these records. That is where job title equals design employee. These filters work more or less like the way you would filter data in a Microsoft Excel spreadsheet. And you can see the results given there. So we have Gail, Joseph, and Sharon as the results. And T-SQL includes many syntax elements that are used by or that influence most statements. So these statements include data types, predicate functions, variables, expressions, control of flow, comments, and batch separators. Okay, now T-SQL basically has various languages, and they're divided into three, so we look at them very quickly. We have the data definition language, that is DDL, which is used to define and manage all attributes and properties of database, including row, layouts, column definitions, key columns, file locations, and storage strategy. DDL statements are used to build and modify the structure of the table and other objects such as views, triggers, SPs, or stored procedures, and so on. And for each object, they usually create, alter, drop statements such as create table, alter table, drop table. And most DDL statements take the form of you either want to create, then the object, alter, the object you want to alter, drop. Drop basically is a destructive statement which you have to be very careful with. And here I would like to caution you, there is nothing like a recycle bin or something of that. So please be very careful when issuing drop statements. Now, in the data definition language statements, the object name can either be a table, view, trigger, stored procedure, and so on. Okay, data manipulation language, that is DML. This is what we use to select, insert, update, or delete data in the objects defined with the DDL. All database users can use these commands during the routine operations on a database. And the different DML statements are: one, we have the select statement. We looked at that earlier on. We have the insert statement. We have the update statement. And finally, we have the delete statements. As I said, these are called CRUD or crude operations. Then finally, we have the DCL, that is the data control language. So this is an important part of the database. So proper steps should be taken to check that no invalid user accesses the data. This is basically what is controlling the permissions to the objects in your database. So permissions are controlled by using the grant, revoke, and deny statements. And the DCL statements are also used for securing the database. And the three basic DCL statements are given below. So the first one is called grant, which we use to grant permissions, or we want to allow people to do something in our database. We have revoke. Revoke, basically, if you misbehave, we might want to have some of your permissions. And finally, we can totally deny permissions. So these basically are more in the database administration part of this. So we might not be looking at some of these in this particular course. So without further ado, let's look at the data types which are available for us. So a data type basically is an attribute defining the type of data that an object can contain, and the data types must be provided for columns, parameters, variables, and functions, which return data values and stored procedures that have a return code. T-SQL includes a number of these base data types such as varchar, text, and int. And all the data that is stored in SQL Server must be compatible with one of these base data types. And the following objects have data types. Now, data types correspond to variables in other programming languages like C, C++, Java, C#, or the like. And basically, so we are saying the following objects have data types. So columns present in tables and views. The data which you're storing there must be of a given data type. The parameters which you're passing into stored procedures must have a data type. Variables, of course, they have a data type. T-SQL functions which return one or more data types of a specific data type, and SPs that have a return code belonging to the integer data types. So various items in SQL Server 2012-2016, such as columns, variables, and expressions are assigned data types. And let's look at the data types which are supported in SQL Server. So we have the system-defined data types. So these data types are provided by SQL Server 2012, and the following table shows the commonly used system-defined data types of SQL Server. So we have the category, then the data types, then the description. So we are going to look at numeric, that is they store values in them. So the first category is exact numerics. So we have integers. So a column of this type occupies 4 bytes of memory space. Now, for integers, just like in the other programming languages, we are actually storing whole values. This is like the number of students in a class, the number of objects in a carton or something like that. So the range you can see there is 2 raised to 31. That is about negative 2 billion all the way to positive 2 billion. We have small int. So a column of this type occupies 2 bytes of memory space, and it can hold integer data from minus 32,000 all the way to positive 32,000. Tiny int, basically, this occupies 1 byte of memory space, and it can hold integer data from 0 to 255. Basically, this would be a good way to store those edges. I don't know anybody who's passed that. Big integer, this is when you're dealing with large integers. This would be a good way to store the world's population. Numeric, basically, this is a column which has a fixed precision and scale. We have one which is unique to SQL Server, that is money. Then we have approximate, we have the float and real. So this is a column which occupies about 8 bytes of memory space. And you can see the range, that is negative 1.79 E positive 308 through 1.79 E plus 108. We have the real, so a column of this type occupies 4 bytes of memory, and the range is given there as well. We have date time. So this is when you're dealing with dates and times, and basically it's stored as 4-byte integers. We have small date and time, basically, which represents a date and time. We have strings, basically called character strings, and we have various types. We have these ones which are non-Unicode, and the ones below it which support Unicode characters. So the first one is char, which stores character data that is fixed length and non-Unicode. The same for varchar. So this one stores character data that is a variable length and non-Unicode with a maximum of 8,000 characters. Text basically stores character data that is a variable length and non-Unicode with a maximum length of about that. So basically, if you want to store CVs in your database, it would be a good field. Unicode types basically stores Unicode character data of fixed length, and varchar basically stores variable length Unicode character data. Then finally, we have the other data types, and we have timestamp. Timestamp is a column which occupies 8 bytes of memory. And actually, this is generated by the computer, and we use this for when a receipt is printed in the supermarket or a transaction in the ATM, something which basically happens at a given time, instance in time. That is what you're calling the timestamp. Now, binary n, basically this stores fixed length binary data with a maximum length of 8,000 bytes. We have var binary, which basically stores variable length binary data with a maximum length of 8,000 bytes. Images, if you want to store images, so stores variable length binary data with a maximum length of about, this is about 1 billion bytes. And basically, the last one, we have the unique identifier. Now, this is guaranteed to give you a globally unique ID, as you can see the abbreviation there, meaning that if you want to store data like something that will uniquely identify an object uniquely, globally, this would be a very good field. Now, we also have alias data types, and basically what happens, you remember in your C class, we had the typedef keyword, which you would use to create your own data type. So this is the same concept you're talking about here. Now, they're based on the system supplied data types, and they're used when more than one table stores the same type of data in a column. And it has similar characteristics such as length, nullability, and the type. We'll look at all these things later. And it can be created when it can be used commonly by all the tables. Now, we want to look at the syntax of coming up with this alias, and it's actually given below. So the syntax is create type, so schema, then type name. From this type, then you give us the precision, the scale, tell us whether it's going to be null or not null. Now, for you to understand this more, I would like you to open a browser. So that is what I'm going to do right now. Come here and type in SQL server, SQL server, alias, whatever you want to call it. Now, what I'd like to tell you is that for this course, we'll actually be using the Microsoft documentation site. So it's a site that you need to get quite familiar with. And from the search results, you can see it's in the first, it's ranked up here. So I'll just right click on this and select open in a new tab. So it opens for us. And what I'd like to mention as well is you have to specify which version of SQL Server that you're using. So in our course, we're actually using Microsoft SQL Server 2016. So I'll click on this drop-down list here and select SQL Server from this list. Then I specify 2016. So you can see this article is about 3 minutes to read, and basically you can go through it and you can see the application. It applies to SQL Server and SQL Azure database. Now the Azure database, as you learned earlier, is the online version of it, and most commands basically work the same way. Now we move on. So you can look at the limitations and restrictions. And then you can see how to go about this using SQL Server Management Studio. We'll be looking at this. I'll show you how to work with this in a moment. Okay, so please come and take some time to read this, and let's continue with the session. Okay, so schema name basically identifies the name of the schema in which the alias type is being created. And a schema, as you can see here, is a basically a collection of objects like such as tables, views, and so forth. Type name identifies the name of the alias being created. Base type identifies the name of the system-defined database based on which the alias data type is being created. Precision and scale is whether you would like to have decimal places and such. Null or not null means whether the user must fill in a value or they are free to leave it blank. So please kindly note that null does not equal to 0 or something of that sort. So it just means that it's something which is not known. Okay, so we have an example. So the following code snippet shows how to create an alias using the create type statement. So create type user type from varchar 20, and we can see that it should not be null. So in the code, the built-in data type varchar is stored as a new data type named user type by using the create type statement. So user-defined types are created using programming languages supported by the .NET framework, and a good example of this is Microsoft C#. Okay, now let's look at the language elements of TSQL. So these are basically used in SQL Server. So I'll be using 2016, 2012 interchangeably because that is what we'll be looking at in this course. For working on the data that is entered in SQL Server database, and they include the following. So we have predicates, operators, functions, variables, expressions, control of flow, errors, transaction, comments, and batch. So we start with predicates and operators. Now, predicates are used to evaluate whether an expression is true or false, or basically unknown at times. And some of the predicates in SQL or in TSQL are given below. So we have the in. Basically, we want to find out whether something matches in a subquery or from a given list. Okay, we'll see an example. Between basically specifies a range of values to test. So whatever it is that you're testing must be in a given range. Like basically we use this mostly for text. Like we want to find people whose name contains an A, ends in an A or something of that nature. Like, contains searches for a precise or less precise matches to single words and phrases, words within certain distance of one another, or weighted matches. And the following table gives you some examples. So the first one is in, and I would like to show you something here I had opened earlier on. So just give me one moment. Okay, so you can see we have this query here. Basically, it's a bit complex for now, but we'll understand what is happening here. You can see the last part here where we are filtering, so the employee job title, we want either a person who's a design engineer, tool designer, or basically marketing assistant. So you can see what is happening here. Now, if we revert back to your slides, that is what is happening here. Between is pretty obvious. So we want to get the user ID, first name and last name. And we want to get this for those employees whose salary ranges between 5,000 to 20,000. The next one is the same thing, but we're interested in finding out these details on employees whose name contains letter H. The percentage sign behaves like a wildcard or an asterisk if you're searching in Windows. Contains, basically, we want to find those salaries which contain 5,000. Okay, let's move on. Now, operators are used to perform arithmetic comparison, concatenation, or assignment of values. An SQL server has 7 categories of operators, and the following table describes the different operators supported in SQL Server 2012 and also 2016. And basically, we have the comparison. So we are comparing two values against each other, or basically an expression as well. So we have the equals, less than, greater than or equal to, less than, equal to, not equal to, and not greater than. Then we have the logical, which basically tests for the truth of a condition. And this one, we actually use the words themselves. That is the and, or, not, as you saw in this browser. Now you can see in the browser, we are actually using the word or, not like the way we do it in languages like C, Java, or the likes. So we're actually using the word or itself. Let's go back. Then we have the arithmetic. Basically, those ones are self-explanatory. This is when you want to add, subtract, multiply, and divide. Concatenation, this is when you want to join two strings. This one behaves like in C, so we use the plus to join strings. We'll be seeing this later. And of course, we have the assignment operator, which is the normal equals sign. Now, just like in the programming languages, these operators, they have a precedence. And basically, the highest is the parentheses or the brackets. Then we have the multiplicative, we have the additive, we have the comparison, then we have the not, and, then we have the predicates, and finally we have the assignment operator. So the following code snippet shows the execution of operators according to precedence. So we have this example given here. So we declare a variable. So the at is how we use to declare variables. So this variable is called this variable is called number, and its type is int. Then we do an assignment operator. So set number, you assign it. So 2 plus 2 times, so open the brackets, 4 plus 5 minus 3. Of course, just like in any other programming languages, we'll begin with the inner brackets. So you'll subtract 3 from 5, then add the result to 4, then multiply that by 2, and finally add the result to 2. And basically, the answer will be 14. Okay, we also have some functions, and basically this makes our life a little bit easy. So a function basically is a set of T-SQL statements which are used to perform some tasks. And the 4 types of functions in SQL Server are given below. So we have row set functions which are used to return an object which can be used in place of a table reference. Example, we have open data source, open query, open row set, and open XML. We have aggregate functions. Aggregate is like when you want to get totals of something. And basically, they assist you in summarization of large volumes of data. For example, we want to get the total sales in a given month. We want to get the average of the student's course in a given class or something like that. We want to get the highest, lowest. So examples are given there, sum, min, max, and so on. Ranking functions, basically they can implement many tasks like creating arrays, generating sequential numbers, finding ranks, and so on. And basically they make it easier and faster by use of the ranking functions. So examples are rank, dense rank, entile, and row number. And we have scalar functions. Scalar functions basically have input as a single value, and they also give us back a single value. Okay, the following table shows the commonly used scalar functions. So we have conversion functions, and basically the conversion function is used to transform the value of one data type to another. Additionally, it can be used to obtain a variety of special date formats. An example is the convert function. We have date and time functions, which are used to manipulate date and time values, and they're useful to perform calculations based on dates and a good example is like now most of us are at home. You want to bake a cake, maybe you want to find out how long it's going to be. So, okay, what I want to say is that let's say a cake expires after 1 week. So you can actually add a week after the date you baked that particular cake or something like that. So some of the date functions are given there. We'll be using some of these as we move on. Mathematical functions, basically they used to perform algebraic operations on numeric values like rand to get some random values. If you want to round, we have that. We have the power function. You remember the POW function we use in C, Java, or something like that. String functions, basically we want to manipulate strings, you want to join them, you want to separate them, you want to find their length and remove extra spaces and on. These are some of the functions which you might want to use. So there are also other scalar functions such as cursor functions, logical functions, meta functions, security functions, and so on, which are available in SQL Server. Okay, very quickly we look at variables. So a variable basically, as you know from your other programming languages, is an object which can hold a value that will change during the execution of your script. So in T-SQL, variables can be classified into local and global variables. And in T-SQL, local variables are created and used for temporary storage, while SQL statements are being executed. So data can be passed into SQL statements using local variables, and the name of a local variable must be prefixed with an @ sign. While on the other hand, if you're dealing with global variables, you basically prefix them with 2 symbols or signs. Now, the value of any of these variables can be retrieved with a simple select query, as we'll see. Next, we have expressions. So an expression is a combination of identifiers, values, and operators that SQL Server can evaluate in order to obtain a result. And expressions can be used in several different places when accessing or changing data. The following code snippet shows an expression that operates on a column to add an integer to the result of the year function on a date time column. So we are getting the sales order ID, the customer ID, the salesperson ID, territory ID, then year of the order date. As basically is used for creating aliases in your columns. So the alias will be current year. So year of the order date plus 1. So we are taking the current year and adding 1 and returning that as the next year. And basically we are getting this from the sales order header table in the sales schema. And the subsequent slide gives us the results of this. We'll actually see this in our queries once we begin working with SQL Server. Now, so that is the results of this. Next, we have the control of flow, errors, and transactions. So although T-SQL is primarily a data retrieval language, it supports control of flow statements for executing and finding errors. Control of flow language determines the execution flow of T-SQL statements, statement blocks, user-defined functions, and stored procedures. So the following table shows some of the commonly used control of flow statements in T-SQL. If else, I'm quite sure we remember how if else works. Basically, this is for branching control based on a logical test. So if a certain condition evaluates to true, you execute whatever is below the if. Of course, if it evaluates to false, you execute what comes under the else. While basically is used for looping or repeating a statement or a block of statements as long as the condition is true. Begin and basically are being used to denote the start and end of a block of T-SQL statements. Try catch, basically this provides us with structured exception handling within the T-SQL language. So this is used to define the structure for exception and error handling. Begin transaction basically marks the block of a statement as part of an explicit transaction. Now, when you're doing all this, of course, you will need to write some comments, and basically this is how we go about writing comments. So comments basically, like you learned earlier on, it's a descriptive text or string that basically denotes what it is that some code is doing. Now, we also call them remarks, and basically they're ignored by the compiler. And comments can be included inside the source code of a single statement, a batch, or a stored procedure. And comments explain the purpose of the program, special execution conditions, and provide revision history. Microsoft SQL Server supports two types of commenting styles. We have the double hyphens. So this, a complete line of code or part of a code can be marked as a comment if two hyphens are placed at the beginning. Now, this is a single line comment. And basically, once you put that at the beginning of your line, it will denote that as a comment. So you can see an example given there. So the comment starts from human resources employee table all the way to human resources employee. So all that is basically being ignored by your compiler. Next, we have the multi-line comment, just like in your C programming language, JavaScript, C++, or any of the other languages that you've learned so far. Now, these comment characters can be used on the same line as code to be executed on lines by themselves, or even within executable code. So everything in the line beginning from the open comment pair to the close comment pair is considered part of this comment. So for multiple comments, the open comment pair must begin the comment and the close comment pair must end the comment. And we have an example given there. Okay, we have batch separators. A batch basically is a collection of one or more T-SQL statements sent one at a time from an application to SQL Server for execution. And T-SQL statements in a batch are compiled into a single executable unit, and we call this an execution plan. Now, the statements in the execution plan are then executed one at a time, and the process wherein a set of commands are processed one at a time from a batch of commands is called batch processing. Now, batch separator is handled by SQL Server client tools such as SSMS to execute commands. An example, you need to specify Go as a batch separator in SSMS. Now, for the newer versions, we'll basically be using the semicolon to separate matches. Reason being that that is what the standard is nowadays. And that is what basically we are used to in working with our other programming languages. However, you can still use the Go, there is no problem, and it still works the same way. So please just use whatever it is that you're comfortable with. Just something to mention beforehand, I'll basically be using the semicolon as the separator. Now, we move on to something I told you to look at, set theory. Now, set theory is a mathematical foundation used in relational database model, and basically a set is a collection of distinct objects considered as a whole. For example, we have a set of students, we have a set of cars, a set of laptops, or a set of whatever it is that you would like to store data about. An example, all the employees under an employee table can be considered as one set. The following table shows the different applications in the set theory and their corresponding applications in SQL Server queries. So we have the set theory applications and the applications in SQL Server queries. So act on a whole set at once. So you query the whole at once. Use declarative set-based processing. So use attributes in SQL Server to return specific data. Elements in the set must be unique. Define unique keys in the table. No sorting instructions. So the results of querying are not retrieved in any order. Now we have predicate logic. So this is a logic. Predicate logic is a mathematical framework that consists of logical tests that gives a result, and the results are always displayed as either true or false. In T-SQL, expressions such as where and case expressions are based on predicate logic. So predicate logic is used in other situations where in T-SQL, and some of the applications of predicate logic in T-SQL are given below. One, enforcing data integrity using the check constraint. We look at this later, what exactly these are. So I'm just going to go through them for now. Control of flow using the if statement, joining tables using the on filter, filtering data in queries using the where and having clause, providing conditional logic to case expressions, and defining subqueries. So let's look at the order of these operators in select statements. So along with the syntax of different SQL Server statements, SQL Server user must also know the process of how the entire query is going to be executed. So this process is a logical process that breaks the query and executes the query according to a predefined sequence in the SQL Server database. And the select statement is a query that will be used to explain the logical process of query execution. So the syntax of the select statement is given below. So we have select, then the items you'd like to select, then the tables, the filter where, group by, having, then order by. So the following table explains the elements of the select statement. We have the select. So this is basically telling us the columns which you would like to get details from. The from basically is the table which you want to get the results from. Where basically is what we're using to filter the rows using the predicates. Group by is arranging the rows that we would like to group by. And then having basically now works like a where, but on the groups. Then we have the order by, which actually sorts the output. And we have an example here. So select, so the columns are salesperson, the order date, we are getting the year from the order date. And this is being aliased as the order year. From the table is a sales order header in the sales schema. A schema basically is a grouping of related tables. Where customer ID, so we are specifying how we want to filter. So the customer ID is 30,084. We want to group by, so salesperson ID and the year of the order date. Having, so we want to count everything being greater than 1. And we want to order by the salesperson ID. Then the second ordering is by the order year. So let's see what exactly happens once we issue this command to SQL Server. So first, the from clause is evaluated to define the source table that will be queried. Next, the where clause is evaluated to filter the rows in the source table. This filtering is defined by the predicate mentioned in the where clause. After this, the group by clause is evaluated, and this clause arranges the filtered values received from the where clause. Next, the having clause is evaluated based on the predicate that is provided. Next, the select clause is executed to determine the columns that will appear in the query results. Finally, the order by statement is evaluated to display the output. Then, so the order of execution for the select statements in the code snippet would be as follows. So we have, now this is the way it was written, but now we want to see how it's actually executed. So the select basically will be evaluated fifth. So we'll start at the from, followed by the where, group by, having, and finally we'll go to the order by clause. And once you run this on the AdventureWorks database, basically it will give you these results. So we've come to the end of the session, and basically this is what we were able to learn in this session. So T-SQL is a powerful language which offers features like data types, temporary objects, and extended stored procedures. SQL Server supports 3 types of T-SQL statements, and these are basically data definition language, data manipulation language, and data control language. A data type is an attribute defining the type of data that an object can contain. The Transact or T-SQL language elements includes predicates, operators, functions, variables, expressions, controller flow, errors, transaction, comments, and batch separators. Sets and predicate logic are the two mathematical fundamentals that are used in SQL Server 2012-2016. Set theory, mathematical foundation used in relational database models, where a set is a collection of distinct objects considered as a whole. And finally, you learned that predicate logic is a mathematical framework that consists of logical tests, which gives a result. Thank you, and have a nice time.